Hi everyone. So now we're going to start discussing an instruction that is very useful for moving values from one area to another. We'll discuss several scenarios, several examples right now, and we'll go through them step by step. So a key to succeed understanding the move instruction. So the move instruction is shown right here. It's MOV right here. You can, if you delete this, you can write it. You see it tells you move. You hit enter. You got it. Notice that you have a source and a destination. The source is what data you want to move. This we'll discuss what type of data can you put in there, and the destination is where you want to move it to. Okay. You will need to use this instruction on your project, so it's going to help you a lot. So it's very important that you understand it. So that instruction would be, if you don't want to use that shortcut that I just used, is right here on MISC and data manipulation. Should be here. So move. So you move a value from from the source to the destination when the rung becomes true. So when this side is true, right now it's always true, right? So you put conditions here to make it true, and when it's true, it's going to move the value on the source to the destination immediately. It doesn't have to stay on. If it turns off after it moved that value, the value will stay there. Okay. So going back to the move instruction, very important to notice that the type of memory that you can use in a move, right? You would you won't not want to move like a bit. It does not to move bit values. It is not made for that. It is made to move actual internal like numeric values, not a bit, but an actual number. For example, if you were to hit right here on the move instruction, double click and hit on the question mark, it gives you a lot more detail on what type of data you want to move, right? Uh, Notice that it says you can move a floating point. So a floating point is any number with decimal. Actually, if you want to go even further than that, actually, so you go to the help file over here, go backwards. So it should be R, which is your floating point. Go from negative 3.4 elevated to the 38 power, all the way to 3.4 elevated to 38 power. It's a 32-bit real value, right? That's a lot of memory right there. If you want to do a signed double word, so double word in this processor is 32 bits. A single word will be like this one, unsigned word, which is a single word, is 16 bits. So depends what type of number you want to store there. If the number you want to move is from 0 to 65,535, you probably want to use this. If your number has a sign, you probably want to use this. So depending on what you use, it's also the amount of memory that it's going to cover. Just like your timers, you see? You got your timers here. That is also a type of structure. So in this case, you go from V0 to V4095. So you got all these memory locations. So V0, V1, V2, V3, V4, where you can store a number, right? All right. So I'm going to go for an example. Let's say I want to go for an example. Let's say I have a timer, T0. Right here, should be able to select it on delay timer by just putting on, right? I go a shortcut, and in here, notice that on my time structure, it tells me how much time you want for your on delay time. Let's say I want to store in a value like D0, right, in milliseconds. Notice that it's in milliseconds, right? So let's say now my on delay timer, it's variable. I can change it, right? So for example, let's say my delay time, I want to use a single timer. I don't want to use multiple timers. Now you got to know how to kind of like the programming you want to do, right? So let's say I want to add a rung, insert rung after cursor. Okay. Let's do another move statement from D0 to T0.acc. Now I'm moving a value of D0 to the timer, actually not to the timer accumulator, but to T0 dot, actually D1, so what's our variable here? D1. So we want to put it here on D1. D0 to D1. Let's use D3. So my on delay time is going to be located in D3, in the memory D3. I'll explain this pretty soon. Give me 1 second. So D3. Okay. Now I'm going to put a condition here. Let's put C10. These are random conditions. I'm kind of doing them. So let's try to do this. So D0, we want D0 to be, instead of D0, we want D1. So notice I'm moving, initially, C10 is true. I'm moving the file, or not the file, the memory location, whatever value I have in memory location D0, from D0 to D3, okay? And if C11 is true, I'm going to move D1 to D3, okay? That value is then used, D3, which is the destination, right? Because I move from the source to the destination whenever this is true. I'm going to move it to D3. So D3 in milliseconds, I'm going to use it as the on delay time. So before, we used to have a hard-coded number there. We would put like a constant number, right? How many seconds we want. This time, we're putting whatever time depending on the conditions are made. All right, we're going to accept it. We'll accept the edits. Do we have the simulator open? We do not. Okay. Run mode. Online with this project. Continue online. Same thing that always tells us. We're going to write the program. Says the program is on run mode. Turn mode. Write to PLC. There you go. Whole status on, and we're going to put it in run mode again. Notice that our timer right now, it doesn't have anything. So our on delay timer is 0 because D3 doesn't have anything. We can prove it. Remember on past videos, we talked about the data view. So D3, what is D3? What we have in D3? Bam, 0. Right? What do we have in D0? We have 0. What do we have in D1? 1. So let's say you want to change these values. These values are coming like from an HMI screen or something like that, or a touch screen where you put whatever time you want to do it, or it depends on a recipe, or it depends on some other logic, right? You want this value, you want this timer to have different values depending on the type of system or depending on the conditions that are made. So let's say D0, let's change D0. We will have to change this to the edit mode. Edit, let's change it to 10,000. 1, 2, 3, which is 10,000 milliseconds. I want to add a condition right here. C12. So I can turn it on and off and reset the timer whenever I want to. This is what here is a bit that it's internal to the PLC SD1. It's always on. Okay. Don't see it as it's the program trying to make it work with what he has. So I didn't have anything there. So he actually put it there. So let's put an on bit. Let's write it. Well, before we even do that, let's move a value around here, right? So let's move 1,000. Look what happens with the 1,000. So right now we're about to move 10,000, actually not 1,000, 10,000, which is 10 seconds or 10,000 milliseconds to D0. D0 is a source here, right? Which is 0. We move that automatically, bam, 10,000 milliseconds, right? So if we were to make, now D3 is still not made. D3 doesn't have anything. So if I make C10 true, turn it on, and I'm going to write that value. Look what happens. Immediately it populates with a 10,000 right there. D3 is 10,000, right? D3, don't matter where it's located, D3 is always going to be 10,000. And on our timer, we have 10 seconds. All right. So now we say, well, let's turn off. Look what happens when I turn off C10. Remember I said it's going to stay there with that value? So I turn it off. It's off. It's no longer executing this. But since it already moved 10,000 to here, it's already in D3. So I already did the move. I already executed the move. It stays there. So when I execute my timer and I turn it on, timer is going to start timing. Well, turn it on. So I start timing to 10 seconds. Now, let's put 30,000 to 3. Okay. And then we're going to execute C11. So notice that my timer is already made, right? And it's still the on delay time on D3 is 10 seconds. Let's turn off C12 to reset our timer. We turn off our timer. It resets our timer. It went back to 0. Now we're going to turn on C11, which before we do that, we need to move this value into D1. So look at D1 right now. It doesn't have anything. We're going to put a 3,000 there. 30,000 milliseconds. Sorry. Which is 30 seconds. So when this executes, it's going to overwrite that 10,000 milliseconds with 30,000 milliseconds. So let's execute that. 30,000 milliseconds. Now our on delay time is 30 seconds. If we execute our timer, C12, now it's going to wait till 30 seconds, right? Even if I turn it off, it's still going to have that value in there. In fact, I could even change that in real time. So let's say I want to move that 10,000 back in, which is C10. C10 turns it on, it moves it. C10, look what's going to happen. Bam, it changed to a 10,000. And if I turn it off, the value continues being there. All right. If you turn them all at the same time, I cannot guarantee, but usually since the program runs from top to bottom, getting all the inputs, executing the logic, and updating the outputs, you're most probably going to get the one that's last. So to prove it, let's do a C10. Let's turn it on. Now I move at 10,000. Now C11. So this should not happen. What I'm doing right now is just to show something, but it should not happen, right? So if I turn it off, Go back there. So you see the last one, even though this is true, again, if I try to turn it on again, look, turn it off, turn it back on, still not moving the 10,000. This should never happen. They should be mutually exclusive, meaning when this one happens, this one should never happen. But if it does, the last one will win the race, right? The last one is the one that's going to be executed last. So it's the one that's going to update that location in memory. Okay, I hope this helps. But going back to the move now, I can do other type of changes. So if I go here, I can move actually a 10,000. Instead of putting like a memory location, 1, 2, 3, I can actually move 50,000 or 5,000, just 5 seconds. Okay. Now I accept the changes right to the PLC. Now notice that C11 it's on. The last, right? Let's turn C off, C10 off. So I got 5 seconds timer. If we set the timer, which is C12, turns it off, resets my timer, I turn it back on again. So I move a hard-coded value into my D3. So it doesn't have to be in a stored location. I can just write it in there instead of just putting it in a file location or in a data block or in a memory location. Another thing that I would suggest, which is very important to know, so that D is a double word. It has a lot more memory, right? If you're not going to use this type of numbers, I would not suggest to use this D, right? D memory location. If you're not going to use, I would say like decimal points, I would not use the R value location. So you can have here like let's say R1 or R0 and have here 10.04 some or 0.65, and I accept the changes right to the PLC. So right now I just moved a value to R0. I'm going to start moving it. So if I turn it on, gotta execute it, right? So you can see it changed it. It rounded off to the nearest one too. So it has double digit, right? So you can see I can use decimal points as well. But if you're not going to use decimal points, I would not use the R. So think about the R when you're using real numbers. So when I say real numbers, it has decimal points. If you're not going to use big numbers like these, I'll suggest you to use the V memory location. I will not suggest to use any other thing. Over here, I did not change it for a timer. I changed it to an actual R value, right? So it doesn't have to be for a timer. It could be any value. So on the accumulator, I said, remember when we started the class, we talked about the accumulator. The accumulation is an actual value, right? So it is not what I would call, it's not what I would call a actual bit. It's not binary, it's an actual value. So you can store values in there. In fact, I don't think on this one, it might let you, it does let you. So as you can see, you can put even floating points in the timer, right? And the reason why is because it didn't even care. It really rounded off to whatever value. So 1,000 milliseconds is the same thing as 1 second. So it didn't put the points or anything. It didn't care. What else I can tell you? So the reason why we bring this move to be is because we can use this move to actually put like a step into it, and we'll be talking about that in the next video. Just make sure that you understand the concept here. Usually if you're going to use small numbers, like on the project, I would use the unsigned word. If it's not going to have a sign, if it's not going to be a big number, I would use this one, a V memory location, which would be like a V0, for example. And you got other V's, right? So V0 to 4,095. You can choose any of those locations. So I set the edits. It's going to round it off right now. So you see it rounded off. So no sign, no decimal points, and it's going to be a small value. Well, depends what you call small. So that'll be all for the move instruction for now. Now, the next video, I'll be explaining an application where we're going to use the move instruction, we're going to use the set reset, we're going to use the on delay timer. And it will help you understand how all this code works together. All right, hope this helped.